Okay, Integrated Math 1, welcome back to another week of social distance learning. I hope you all are staying safe and healthy and getting through this together. Hopefully it's gotten a little easier this week than last week. I'm going to go over, this is 9.4, so we're going to do finding the areas of shapes on the coordinate plane. But first we're going to look at a couple different things. So you're going to work through this. Feel free to pause the video, go back, find all the things that you can find helpful. All right, so the first thing we're going to do here is types of triangles. Well, if we have a triangle, this little sign means that this side is equal to this side, which is equal to this side. So something like this is an equilateral triangle. Equilateral triangle, meaning that all three sides are equal. Okay, so that's one situation. This one, none of the sides are equal. This is different than this, which is different than this. And what these signs really mean is that these are three different side lengths. So this is called a scalene triangle. S-C-A-L-E-N-E. And this is when no sides are equal. They're all different side lengths. All right, so then this one, you can kind of see here that these two are equal and this would be longer. So if we have two equal sides, what we have is called an isosceles triangle. Right, so we have an isosceles triangle, and that has two sides that are equal. So two sides are equal. And then here, this is just kind of a different one, but this is just a right triangle, right? It's a right triangle. Or we'll just keep using this symbol for triangle. And that has a 90-degree angle. Okay, so we got four types: scalene, equilateral, isosceles, and a right triangle. So let's move on, and we're going to figure out which one this is. Now, if you look at it, you can kind of see that AB and BC look like they might be equal. So we're going to use the distance formula to figure out, right? Because we have a diagonal here. So remember that our distance formula is the change in x and change in y, right? So change in x, change in y. So we can see here that this goes 1, 2, 3, 4, right? So this is going to be 4, and then this goes up 3, right? So our change in x plus the change in y, we're going to put a square root here. It's going to be 4 squared plus 3 squared, right? So that is going to give me square root of 16 plus 9, which is equal to square root of 25, also known as 5. All right, so then we look at BC. Well, BC goes down 1, 2, 3, 4, and then over 1, 2, 3, right? So BC is the same. We have change in y in this case. Doesn't matter which one you write first because you're just adding, right? So then you get 16 plus 9 equals square root of 25. And then we have two sides equal. So we know that it is an isosceles triangle. Okay, So moving along. So let's look at a couple other ones. Now, if you look at this one, well, you can see right away, we got to figure out if it's scaling, isosceles, or equilateral, right? So just want to figure out the side lengths, right? So AC, well, that's a straight line, so we're just going to count down 1, 2, 3, 4. So that is a side length of 4. AB, well, that is down 1 and over 4, right? So change in y, change in x. So 1 squared plus 4 squared, well, that's equal to, this is 16 and this is 1, so that's equal to square root of 17. And then you can clearly see that BC would be different as well, because it's 1, 2, 3, 4, and then it goes up 1, 2, 3. So once you know that, you would have 4 squared plus 3 squared, and that's 16 plus 9, which would give me square root of 25, which is also 5. But all three, no sides are equal, right? They're all different lengths, so this is going to be scaling. No sides equal. Okay, now if we look at this one, we could try to figure out what's going on here. But you can see this, like, we don't even have to write out the whole thing, right? If we go over 1, 2, 3, and then we go down 1, 2, 3, 4, 5. So we know that this changes 3 and 5 for AC, right? So that's going to be 3 squared plus 5 squared. And then we know that BC goes down 3 and then over 5 as well. So you don't even have to do all the simplifying. You can see that this is going to be 3 squared plus 5 squared. And these two sides are going to be equal, so this one is isosceles triangle. Because two sides are equal. Okay. So now we're going to look at some quadrilaterals. Remember, quadrilateral just means four-sided polygon, or 4 sides. So how can you prove that this is a parallelogram? Well, we need this side to be equal to this side, and this side to be equal to this side. So let's start with RS equal or congruent, but we'll just say equal to QT. Right, so if we look at it, this goes down 4 and then over 1. So this is 4 squared plus 1 squared. And then this also goes down 4 and over 1. So this is 4 squared plus 1 squared. So both of them are equal to square root of 17. So that works, right? Now we just need to look and see, is QR equal to ST? So we're going to go here, we're going to say QR equal to ST. We're trying to figure that out, right? So we're going to go up 2 and over 5 here. So QR is going to be 2 squared plus 5 squared. And then ST, well, we're going to go down 2 and over 5. And remember, we're just looking for the positive change, right? How much does it change? So then this is going to be 4 plus 25. I mean, you can see that they're equal. Oops. And then we're going to be left with square root of 29. Okay? Now this can be 4 plus 25, and that will be square root of 29 as well. So since these two are equal and these two are equal, we know that it's a parallelogram. So therefore, it is a parallelogram. Okay, so the next three, we're going to find the areas of some different shapes here. Okay, so let's start with this first one. So it says show that ABCD is a trapezoid. Well, the way to show that is that you have two right angles here, and then you have one, we'll call this base, let's call this base 2, even though it's at the bottom. That's fine. And then we have base 1, and then we have height. So remember from last class, we said that the area of trapezoid, we'll just make a nice little symbol for the trapezoid, is equal to B1 plus B2 over 2 times H. Okay, so if we can find these three side lengths, then we can compute the area. So we're going to go here and we're going to say B1 equals, well, that's AB. So I'm going to count the change. I go up 2, and then I go over 1, 2, 3, right? So I'm going to say, well, this is equal to 2 squared plus 3 squared. So that is going to give me square root of 9 plus 4, and that's square root of 13. All right, so we'll get down, we're working towards finding the area here. So then this one is going to be CD, and that's going to be equal to, well, I'm going to go over 1, 2, 3, 4, 5, 6. Yeah, so we got 6 here, and then we go up 1, 2, 3, 4, right? So 6 and 4, well, that means this is going to be 6 squared plus 4 squared. And that's going to equal square root of 36 plus 16 equals square root of 52. Now, last one we got to find is H, right? And H is easy because it goes down 2 and over 1. So H equals BC, which is equal to 2 squared plus 1 squared. Well, that's just going to be 4 plus 1, which is equal to square root of 5. Okay, so now we're going to take that formula. So here's we're finding the area of the trapezoid, right? So the area of my trapezoid, oops, let's get that shape right. So the area of the trapezoid, I just tend to use this kind of symbol for a trapezoid all the time. Anything close to that will work. So B1, which is square root of 13, plus B2, which is square root of 52, right, over 2 times square root of 5. Now you might be thinking, well, what number is that? Well, if you have a calculator, I would put this into a calculator, and if you do that, you get that it's about 12.093 units squared. All right, now if you don't have a calculator, that should just be a little dot there. If you don't have a calculator, you could just leave it like this, because really that is expressing the amount that we're looking for. Okay, so that's finding the area of this trapezoid. All right, 2 more. So this one says plotting a polygon. Okay, so I'm going to start here. I kind of already have my dots here from earlier, but negative 3, 5. So this is going to be my A, right? And then my B is going to be at 2, 5. All right, and then C is going to be at negative 1, C is over here, negative 1, negative 1. All right, so got my points, and then D is at negative 6, negative 1. All right, so I'm going to take a minute here and connect all of these. Well, that is not how I want to do that. Let's go back one. There we go. Use this tool. All right, so I'm going to connect this. Connect C and D, B, C, and AB. Okay, now, once you do this, you can quickly see, well, we remember that one thing we can say is that area, we know that area of a parallelogram So we'll just make a little parallelogram, is equal to base times height, right? And the height has to be this vertical height here, right? So if we look at our height, that's our height and that's our base. Well, really easy to see here. We just count down 1, 2, 3, 4, 5, 6. That gives me a height which equals 6, and this base equals 5. All right, so finding the area here is actually pretty easy. We're just going to input our numbers for the parallelogram, and we get the base is 5 and the height is 6. So it's an area of 30 units. We don't have a unit, so we just put units squared. Okay, so that's plotting one, then recognizing the shape, and then from the shape you can go ahead and find the area. All right, one more. So this is a rhombus, but if I didn't tell you that, you could kind of figure it out, because what you would look at here, well, this goes over 3 and up 4, right? So what it's saying is that the area of this one, so LK is equal to 3 squared plus 4 squared, which is equal to 9 plus 16, which gives you square root of 25, which is equal to 5, right? And so you can notice here that ML is 1, 2, 3, 4, 5. So ML is equal to 5. And if I did the same thing with MJ, 3 and 4, well, that's equal to 5 as well. And then my final one, JK down here, we know is equal to 5. Okay? So all sides are equal, so that concludes for sure that it is a rhombus, if it asks you for that. Now, when we do area of a rhombus, we need to do, so area of, I'll make my rhombus kind of like that, pretend those were straight lines, is diagonal 1 times diagonal 2 divided by 2. All right, so I got to find the area of these diagonals. Now, if I'm going to go do that, I'm going to draw my diagonals here. And we'll call MK, why don't we call MK is like D1, okay? So that's going to be my D1. And then JL will be my D2. All right, so what you need to do here then is just go ahead and count down so I can find MK. All right, so I'm going to go down here a little bit, but I need to find MK. Well, MK equals, we're going to go down 4, so 1, 2, 3, 4, and over 2, right? So 4 squared plus 2 squared, which will give me 16 plus 4, which equals square root of 20, which could be simplified to square root of 5 times square root of 4 times square root of 5. So that's 2 square root of 5. All right, JL is my other diagonal that I need, okay? And that one is going to give me, well, I'm going to look here. This is a little bit tougher, but we're going to count over 1, 2, 3, 4, 5, 6, 7, 8, right? And then we're going to go up 1, 2, 3, 4. So count over all the way here, plus 4. So that's going to be 8 squared plus 4 squared, which is going to be square root of 64 plus 16, which gives me square root of 80. Square root of 80 can be simplified. Square root of 16, square root of 5, be 4 square root of 5. Okay, so now we got to finish this up, right? Because we need the area. So the area says that we get D1 times D2 over 2. Well, in this case, that's just, this is equal to D1, and this is equal to D2. All right, so we're going to get 2 square root of 5 times 4 square root of 5 divided by 2. All right, so we're almost done here. We just got to simplify. Well, 2 times 4 is 8, and square root of 5 times itself is just 5. So that is going to give me 40 over 2, which is going to simplify to 20 units squared. All right, so that's how I get the area of this rhombus. I use the distance formula to find the two diagonals. And once I find those, then I just am doing diagonal 1 times diagonal 2 and dividing by 2. All right, so that's it. That's a little good intro on finding area using the coordinate plane. You're going to do more practice on this and then do a final assignment before you go to Semana Santa.